series of computer network subject. In this video, I will explain some protocols that are in our network layer of OSI model. So that protocols are Network Address Translation NAT and ICMP protocol. I am Nishan Singh, Assistant Professor in IT Department of LG Institute of Engineering and Technology. So when we are talking about the network layer in the OSI or TCP/IP model, that works for the mainly different three functions that are related to the routing information, IP information, and error correction mechanism with the help of the packet transmission. So basically, if we are talking about some important protocols that are Internet Protocol IP with the different version IPv6, IPv4 with the IP security IPsec. Next algorithm is related to ICMP and ICMP. That protocols are mainly used for the error correction if the packets are not successfully received. So how can we identify a particular packet is received or not, if destination is unreachable or not, if any receiver is available or not. So that type of information and group information is done by our ICMP and ICMP protocol. If we want to identify our particular destination's IP address and MAC address, then we are using ARP and RARP respectively. The other protocols are used for routing information. The routing information is given by our RIP, OSPF, BGP protocols. And we mainly use here network address translation for the purpose of translating our public IP into the private IP. So different protocols are used for the different purposes here, but mainly we are focusing here in two protocols in this video, that is ICMP and NAT protocol. Now let's start with our first protocol, that is NAT, Network Address Translation. So what is the motivation or goal to use this particular protocol? So when we talk about some scenario where we are using the IP address to logically identify our machine from the network. So when the particular uses of IP is increasing over the uses of internet, then and sometimes what happen here, limitations of IP is changed, and in real time number of hosts and number of devices uses are increased. So when the ISP is assigning any IP address to devices, then it is known as a public IP address. So if all the devices having public IP address, then in future what happen here perfectly, number of ranges of IP address will be sorted. So for that different methodology will be used. For one of them solution is IPv6. But when we are using IPv6, the entire structure of IP is changed, and that structure is followed by all the users which are use the current internet, and all the hardware also will be implemented according to the IP version 6. But nowadays we are using the concept of network address translation. Network address translation, NAT is help us to convert that IP address, public IP address of ISP into the particular local IP address. So there are many advantages of NAT here. So first advantage is range of addressing not needed from ISP. Suppose if we have one organization, and that organization if we have number of devices, so from the ISP we have to purchase only one public IP, and we are assigning the private IP addresses to particular organization devices. When the movements are known from the inside to outside our organization, that IP will be converted with the help of NAT. So this is our aim, how we can reduce the number of IP addresses. So this is his biggest advantage, and our job, whatever the problems is occurring into the terms of number of IPs, that will be a help by our NAT protocol. Next is change address of devices to the local network. So we can assign any IP address to our local machines because it is not publicly available. So this is the another advantage. Our public IP address is one that identify our organization, but our devices IP address are not known to the publicly. So here security is also done by indirectly by the NAT protocol. Also we can change the ISP without changing the addresses. So once we are assigning the IP address to our devices, And after that, if we are assigning or we are changing our ISP, so there is no need to change our device's IP address. We have to just change one public IP which are assigned by our ISP, and that is translated by our NAT protocol. And devices inside local net not explicitly addressable at the outside world, that is the security plus. So these are the four biggest disadvantages which are covered by the NAT. Now let's understand how NAT will work and this is the scenario for that. So we can see here one local network is available with the help of this particular IP, that is the IP of class A addressing. Now here one router is available. Using that router, our particular request is of global IP addresses is coming inside and come outside. Now, how exactly our devices are identified throughout the networks? So, when the request is come inside the network, our network address translation is converting that IP. So, NAT having the methodology that converts our public IP into the some specific IP that will be maintained by NAT table. So all the incoming and outgoing IP addresses are maintained by NAT table, and that table is assigning that public IP to the particular local IP and that local IP to the public IP. So this is the basic idea how the NAT is working. So now we are moving to the implementation part. So NAT router must be implemented here. Following three things. First is outgoing datagram. That contains source IP address and port number. That will be implemented for every going datagram using the NAT. Next is remembrance. So NAT must be remember its networking translation table. So where every source IP address and port number to NAT IP address and new port number. So when any device which are in our network, when requested for some data items, it will first enter into the NAT table. NAT will assign new IP address and port number for that device, and that will be remembered by network address and translation. Now that request is going to the outside of the particular organization. When request is come with the answer, then NAT will map again from this previous request and it will give the response to the specific host. That will be a third part, that is a incoming datagram. So in incoming datagram, it replaces the net IP address to the new port, and the destination field of every incoming datagram with the corresponding that contains the source IP address and port number that will be stored in already in NAT table. So these three basic fields will be maintained by our NAT table. Now understand all these three steps with the help of this animation. So NAT will assign this type of wide area network, that will be a public IP address and our LAN side address. So according to this figure, we have three data members here. One router is available with the NAT implementation, and this is the rest of the world which is use our public IP. Now suppose our one device that contains IP address 10.0.0.1 wants to communicate with the internet. So what happened here? That particular device is requesting, because now it will be contained as a host. So host having some IP address and its port number. Now NAT will convert that IP address into some specific IP address that will be maintained in the NAT table, and that entry will be maintained for that particular host. Now using this particular data item, we can see that data item will be maintained here, that it's all the information and NAT, and that new IP address will move to the outside of that particular range. Now when the response is generated by this outside world, it will arise to our NAT table. That NAT table will map that things, and from this remembrance table it will give the response to the specific IP address that will assigned by that host. So this is the scenario how exactly NAT will be helpful. Now we are moving to this particular some controversial thing of NAT. So when we are talking about NAT, so it's having 16 bit of port number. So simultaneously it's around 16,000 connection will be maintained, but it must be implemented at a router that will be work at the layer 3 protocol. So for that, we have to use some P2P applications that support these things. If applications are not supported NAT, then it will be not be map version. So this is the disadvantage or limitation of NAT protocol. If NAT is not available, then we can use IPv6. So as earlier I discussed what is the disadvantage of if we are directly using the IPv6. Now we are moving to the next protocol, that is the ICMP protocol. Now ICMP stands for Internet Control Message Protocol. So it is used by specifically host and router to communicate network layer information. If any host is sending the data and it assumes that intermediate routers are transferring my data to the destination, but exactly what happened in the network, that network information is given by our ICMP protocol. So ICMP protocol gives the function of error reporting. For example, destination unreachable, network problems, port numbers, protocol number. If particular destination is available or not, that will be handled by echo request and reply. So this type of facility related to network, that will be maintained by our ICMP protocol. If we are talking about how ICMP message format will be worked, so it contains only three parts: type, code, and particular message type. How it will be worked. So when we are talking about the message type, it might be this type of. If we are talking about destination unreachable, that means packet could not be delivered to that particular host. If we are talking about echo, it asks the machine if it is alive or not. If echo reply is coming, it must that it is alive there. If we are talking about time exceed, that means time to leave field is hit to 0. If we are talking about source queries, then that will be a chalk packet message. So according to the message type, our host or router will understand what is the exact situation of our network. For each and every here method, it converts a type and code. So for example, if we are talking about echo reply, if we are performing a ping operation, then it will be known as a type 0 and code also 0. If we are talking about destination network unreachable, for their type is 3 and code is 0. So when we are talking about code type 3 is used for all the destination work. The same way, if I want to use type 3 and code 7, so it is used for destination host unknown. So the same way we can use the number of types that will be used for destination. The same way, if I am using type 11 and code 0, then it is used for TTL expired. Time to leave field is expired in up to the 0. So this is the message format that will be used by the intermediate router and host. Now how exactly it will be performing? So when we are talking about TTL field, so TTL having some specific value. When the destination source is sending the data, and when every time the data is transferring to the next router, TTL field will be decreased. If TTL becomes 0, that means our data is moving in the network, but it cannot be successfully received with particular destination. So when the TTL becomes 0, it understands that my data is not received by that particular destination, so that packets will be transferred again. So with the help of this type of messages, our source or host and intermediate router can transfer the network information. That can be very helpful to successful receive our data at the destination. So in this video, I discussed about the important protocol NAT, how it will be helpful, and ICMP protocol, how it will be helpful for error correction of our network layer. So thank you for watching this video.